Hello guys, welcome back to today's live. This is day 3 of our preparation for this year's WAEC physics exams. This is to enable you score A1 in your physics because it is possible for you and to be able to score that particular mark in your physics this year. So we are wishing you the best. Now, in our last class, we stopped at question 12. If you have not watched our previous episode, I've given you tips and tricks on how to answer physics questions and what to expect from physics exams. So please do well to watch our previous videos because they are going to help you pass your exams perfectly. And this is day 3. If you are joining us, please drop your location, and if you have questions or a particular topic or area of concentration, you can drop them in the comments. I will reply to them as we proceed in this live session. So if you are ready, let's go. If you observe in our previous one of the episode, the first day, I told you that some of the questions you are going to expect close to 70%, right? 70% of your question will come from SS2 work. So, and you can see some proofs, you can see facts about that from this particular question of last year, and you can check previous year's question. You see the SS2 dominates the questions, both practicals. Also, as we progress, I'm going to give you some formulas you must memorize and you must know before you enter your exam hall. Now, with this, you realize that this is the formula we are going to use. Hence, what is missing? Our V is missing. So V is unknown. How can we find V? It says, and the wave travels a distance of 3.5 cm in 1.5 seconds. So we know that from motion, we know that velocity is distance over time. And we are given distance here, right? What is our distance? Our distance is 31.5 cm divided by 1.5. So if you do this, our V will now equal what? If you use your calculator, our V will give us 21 centimeter. V will equal 21 cm per second. Alright, 21 cm per second. Is that clear? Then we need to convert it to meters. Hence, we are going to have V to be equal to what? If you divide by 100, you have 0.21. 0.21 meters per second. That gives us our what? Velocity. Hence, we are looking for frequency. I will know that frequency equals what? From here, we'll make F the subject of the formula so that we'd say F equals V over lambda. Is that clear? Because we know that V equals F lambda. Hence, we are going to have this. Hence, we now have F equals 0.21 divided by, what is our wavelength? 0.035. 0.035. So that our F will now equal what? If you punch your calculator, you'll see that our F will equal 6 hertz. 6 hertz. So let's return to our question. You see that option B is the correct answer. Is that clear? So please do well to memorize V equals F lambda. It is gotten from V equals distance over time. So once you know your formulas for motion, you'll be able to memorize most of the formulas in physics because those formulas are the foundational formulas to which other formulas are gotten. Is that clear? Please take note of that. Now, we're going to proceed with question 14 now. Question 14, the speed of light in medium A is... Question 14, the speed of light in medium A of refractive index 1.5 is 2.0 times 10 raised by 8 meters per second. Determine the speed of light in medium B of refractive index 1.2. Is that clear? So if you observe this question, what can you say about the given data. We are given the speed of light in medium A, which is velocity now. So we have V of A to equal what? 2.0 times 10 raised to the power 8 meters per second. Then we are given our refractive index to be 1.5. Is that clear? So determine the speed of light in medium B. We are looking for V of B of refractive index 1.2. Is that clear? So if you observe this particular question, you will know that we will need to solve this particular question perfectly in order to get the correct answer from this. So to solve this question, we are going to apply this formula since we are looking for V of B. So V of B, if you make it a solved formula, we have V of A multiplied by the refractive index of A divided by the refractive index of B. Alright, so that V of B will now equal V of A is what? 2.0 times 10 raised to the power 8. Okay, multiplying N of A 1.5 divided by 1.2, which is lambda. You are done. Exactly. So for us to achieve this, we can bring in T into V equals F lambda. Since we don't have F, we can replace F with T. And how are we going to achieve that? We know that V equals F lambda. Okay, I will know that T equals 1 over F. Exactly. Hence, I will know that F equals 1 over T. We can substitute this into this, so that I'll have V equals what? 1 over T times lambda over 1. So that V will now equal what? Lambda over T. So by substitution, what do we have? 360 and 600. So we'd have 360 equals what? 600 divided by T. So we cross multiply, so that what do we have? We now have T to equal 600 divided by 360. If you do this, what do we have? 1.667 seconds. This gives us our period, which has to do with time. So our answer is B, or C rather. Our answer is C. I hope you are following. So please, you can see how sound wave is dominating this question. Don't joke with sound wave. Very important. Don't joke with sound wave. Everything you need to know, you stay tuned to this channel. I'll guide you. And also, as you are reading, also practice perfectly. Then we have our next question, which is question 16 now. Question 16, in which of the following levers is effort applied? Okay, in which of the following levers is effort applied between the load and the fulcrum? Between the load and the fulcrum. That's the question. So this has to do with SS1 work under machine. If you have not read machine, please try to do so, because it will help you out. So this has to do with the third level lever, or the third class lever, because the effort between fulcrum and load has to do with the third class lever. We are referring to load and fulcrum. It has to do with the third class. And if that is the case, then our answer becomes the sugar tonnes. That's the answer, sugar tonnes. Please go and check, go and read more about ampere. That's the current here. Then we're asked to calculate the current in the 3 ohm resistor. So for this, we're also going to find our I for this. Okay, then in doing so, of course, we must, in question 18, they are asking us for the terminal PD of the battery in the diagram. They are asking us for the total voltage supplied, the total potential difference supplied through this battery, which is cell. If there are 2, it becomes battery. Alright, so we have 3 questions in one, which we are going to solve here. So the current flowing through the 6 ohm resistor, alright, we can move directly and find the voltage. If that's the case, then we can be able to find our voltage from here. We know that from Ohm's law, V equals what? IR. So V will now equal 1.5 times 6. 1.5 multiplied by 6. What are we going to have? V will now equal 9 volts. Is that clear? So 9 volts is what we're having here. Then the current in the 3 ohm resistor, how are we going to do that? We know already that we have 9 volts. We know that 9 volts is what this man is using, isn't it? Because we know that voltage in series are different. Is that clear? Hence, this is not the total voltage. Is that clear? So please take note of this. Now, since we are looking for the current in the 3 ohm resistor, then we can say from Ohm's law also that I equals what? V over R. Is that clear? If I equals V over R, then we can say that 9 divided by 3 will equal what? 3 ampere. So the current here is 3 ampere. 3 ampere is flowing into this circuit. Is that clear? So if 3 ampere is flowing, but the given parameter network, the total current splits in the ratio 2 to 3. The total current, alright, split in the ratio what? 2 ratio 3. The total current split in this ratio because we're having a 2 ohm resistor and we have 3 ohm resistor. So how are we going to achieve this? We can achieve this now by saying I of 3 ohm resistor will equal what? 2 over what? 2 plus 3, alright, multiplied by the current entering 1.5. Okay, if we do this, let's punch our calculator, then this will give us 0.60 ampere. Is that clear? 0.60. So our answer is an option D, 0.60 ampere. Then calculate the terminal PD of the battery in the diagram. We know that for us to find the terminal PD, we need to find our total resistance in the circuit. So RT will now equal what? Look at the circuit. 2 parallel 3 plus what? 6. 2 parallel 3 plus 6. That is what we're having. So that if we expand this, I'm going to have 3 times 2 over what? 3 plus 2, then plus 6. So that everything will give me 1.2 plus 6. 1.2 plus 6 will give us 7.2 ohms. So that's the total resistance in this circuit, 7.2 ohms. Is that clear? So permit me to wipe this. Let me clean this. Alright, RT equals 7.2 ohms. Alright, now we have our RT. We are looking for V. because we know that V equals IR. So what is our I? We know that I is 1.5. So V equals 1.5 times 7.2. So that V will now equal 10.8 volts. So our answer is C. Now, based on the secret and tips I've given to you in my previous videos, I've told you that WAEC like their answer to be in decimal points. If you have been observing, you'll be seeing that the answers are always in decimal places, 2 decimal places. When solving your section B, your theory, make sure you leave your answers at least in 2 decimal places. Both your practicals and your section B, make sure your answers are in 2 decimal places. Please take note of this instruction because it is very important to your passing of WAEC. So question 19 now. Please, if you have any questions, you can drop them in the comments. And if you are joining us live, please, you can do well by dropping your location. And if you have any question, you can drop them in the comments so that I'll do well to answer them. Is that clear? So let's begin quickly with 19. What do I have? I have 1, 2, 3, 4. Is that clear? So if I have 1, 2, 3, 4, it means I will divide this by 4. So I'm having 4 half-lives. Is that clear? Then we are given 40 days. We are given 40 days. Hence, let me change my pen. Since we are given 40 days, our half-life will now equal what? 40 divided by 4, which will give me what? 10 days. Can you see it? I'll have 10 days. So my answer is C. Can you see that it's in decimal place? So please, your section B, don't joke with decimal point, please. Even if your answer is 10, write 10.0 or 00 and leave it where plus the SI unit. Is that clear? So please take note of all this. It will help you to pass your exams perfectly. Now we move to question 21. Question 21. Question 21. Which of the following reasons explain why the walls and ceilings of a standard concert hall are usually covered with perforated parts? 2A. Now, if you observe, this is under sound wave. How many questions have you observed are coming from sound wave here? So, if you are not good with sound wave, you have issues, I'm telling you. So, for this, we know that if you are covering your walls with perforated parts, if you have been to radio stations for excursions or television stations for excursion or anywhere at all that has to do with communication, you'll see that their walls are always padded and sometimes their ceilings are also padded. Sometimes they use curtains on the wall. Is that clear? So what is the rationale behind this action? It is to reduce the effectiveness or the effect of reverberation. Is that clear? Because we have what we call echo. So, but echo, a continuous process of echo gives us reverberation. Is that clear? If it is only one, you say echo. But when it continues, it gives you reverberation. And to avoid that, it means that option A says what? Increase the intensity of sound wave. Wrong. Increase the loudness of sound wave. Wrong. Reduce the effect of reverberation of sound wave. Perfect. Decrease the frequency of sound. Wrong. So our correct answer is C. So take note of this. Echo. Very important. If you understand echo, then reverberation will be simple for you. Question 22. A bucket of water of mass 10 kg is swung in a vertical circle of radius 1.2, while the lowest position of the swing is, while at the lowest position of the swing, its speed is 5 meters per second. Determine the tension in the string. Take G to be 10 meters per second squared. When you hear tension, you are dealing with force. Exactly, you are dealing with force, which is why you see your options are in Newton already. So if you fail to do that, then you are going to have issues. So based on this, let's extract our given data. We have a bucket of mass. Our M equals 10 kg. It's swung in a vertical direction. And we have our R to be 1.2 meters. You can see the SI units are in standard unit. While at the lowest position of the swing is speed. V is 5 meters per second. Exactly. Determine the tension in the string, and we're given G to be 10 meters per second squared. So that means we need all these parameters to be able to solve this question perfectly. So from what you've been taught in SS2, all right, you know that T, tension, equals what? Weight. Exactly. W plus what? Centripetal force. If you are dealing with that, mv squared over what? R, because we are given radius here, and we are given mass, and we are given velocity. So we can use this. So that our tension, since we are given G, will become mg plus mv squared over R. Is that clear? So if you wish, you can decide to cancel out m, but here let's proceed. So that T will now equal 10 into 10 plus, what is our mass again? Our mass is 10, isn't it? So we have 10 times what? What is our V? Our V is 5 squared. 5 squared divided by our R is 1.2. 1.2. Is that clear? So with this, what are we going to have next? 10 times 10 will give us what? 100 plus 5 squared. We have 10 times 25 divided by 1.2. So that our T will now equal 100 plus 10 multiplied by 25 will give us 250. Isn't it? Divided by 250 divided by 1.2. So that this will have 350 divided by 1.2. What are we having next? T will now equal what? 1.2 to give us, if you do this, what are we having? You will have 308. Please verify for us. 308 Newton. This gives us our final answer. 308 Newton. Is that clear? Please, if you have any issues, you can decide to, let me guide you. You can decide to solve this. Okay. You can decide to solve for this. 250 divided by 1.2 before you add to 100. It will help you out perfectly. Is that clear? So that is that for these. So let's continue with question 23, and this has to do with SS2 work. A man's near point is 30 cm. Which of the following eye defects is the man likely to suffer from? Which of the following eye defects is the man likely to suffer from? That's the question. Exactly. Now, what is the normal near point for a normal human? It should be approximately 17 cm, right? Yes, for a normal eye. So if you observe, this person's near point is greater than 17. It is 30 cm. So if that's the case, then the man is likely to suffer from what? Hypermetropia. Hyper because it is beyond the normal near point for a normal human being. Exactly. And it indicates long-sightedness. So this indicates long-sightedness. Take note of this particular question and also answer. All right. Then question 24 reads, white light can be produced by a combination of which of the following combinations will give you white light? That is the question. And this is under SS2 work. Okay, it is under what? Refraction of light waves. Exactly. Which light can be produced by a combination of this? And we know that when light is splitted to 7 colors, right? Okay, and what? And green. For secondary, we are going to have yellow here. Okay, we are going to have magenta. Where are we going to have magenta? We have our magenta here, and then we have our cyan here. Exactly. And if you draw your straight line, this way, at the center you have white light. Exactly. So any combination here should give you white light. So by indication, what do you think we're going to have? So white light can be produced by a combination of 1. Magenta, yellow, and cyan. Are you here? Magenta, yellow, and cyan. Is it possible? So based on this, we say white light can be produced by a combination of magenta, yellow, and cyan. If you check, I have magenta here, I have yellow, and I have cyan. It is possible. Then red, blue, and green. Red, blue, and green. Correct. Are you here? Then what again can we have that can give us white light? Magenta and green. This is magenta, okay, and this is green. So if you observe, what will be our answer here? Our answer will be C. Is it C or B? Our correct answer is B. Is that clear? So take note of this particular answer. This gives us the answer to this particular question. So let's switch to question 25. Alright, this will be our last question for today. I'll be answering your questions if there are any. Now, the diagram below shows a beam of light incident on a mirror. Such a mirror can be used as what? This mirror, what can it be used for? If you observe, the ray of light is incident. Now look at your arrowhead. Can you look at the arrowhead? That means the ray of light is traveling this way. It hits the surface and it is then deflected. Alright? Can you see? It goes this way, it returns this way. This goes this way, return this way. This goes this way and returns this way. So what kind of mirror is this? What can it be used for? We have surveillance mirror, we have makeup mirror, we have reflector, a microscope, we have depressing mirror. If you observe this particular mirror, the reflected rays, you can see that they are diverting. They diverge. Okay? You can see from the options we are having, they diverge. And if that is the case, the mirror, if you observe, is it concave or convex? Based on the part that is used. You can see the coated area here. So this is what? A convex mirror. This is a convex mirror. Is that clear? So, and convex mirrors are used as what? Surveillance mirror. They are used for surveillance. So we can, the best answer to this question is option A. Yes, is option A. Is that clear? So we are going to stop here for today. If you have any questions, you can drop them in the comments. I will do justice to your questions as I'll be ending this live. Tomorrow I'll be coming live again to continue with question 26. And before then, look at the question. I want you to go through this question before tomorrow. You can screenshot it so that tomorrow when we come live, you will drop your answer in the comment section. Is that clear? So that is that for today's class. I hope to see you tomorrow. If you have not subscribed to this channel, please do so and tell your classmates, your friends about this channel. We'll be anchoring students with tutorials before the exams. Basically, I focus on physics, and if we have time, we'll go into mathematics. But for now, I want you to pass physics with A1 because it is assured. So do well to share this video, subscribe if you haven't, like, comment, so that YouTube can project this video to a wider audience. Thank you for joining us today. I remain your host, IP John. I hope to see you tomorrow the same time.